Hi guys, Levi here from Bright Young Brains. Today we're going to be working on inverse functions. This is specifically term 2 work that most of you guys have definitely not yet started with, right? So we're going to work on the basics, and then we're also just going to touch on a few other topics before we look at a few examples on inverse functions. Okay, so key thing is, right, when we deal with inverse functions or functions in general, right, the one thing we want to be able to recognize, or the one thing that we want to always be able to answer, is a question that will always ask you what a function is, right? So if I can just put that into simpler words, when we're working with inverse functions, right, you basically want to know the definition of a function. So you may be thinking to yourself, yes, I do know what a function is. However, in grade 12, right, when you're going to be asked what a function is, you want to keep in mind that firstly, a function is a graph that passes what we call a vertical line test, right? So what I'm going to do is I'm going to sketch out a bunch of graphs, and then some of them will be functions and then some of them will not be functions, so that we can explain what we mean by the vertical line test, right? Cool. So what we have here, right, is a few sketches. A few of these graphs are familiar, right? We have a straight line graph, a parabola, an exponential graph. This is new, right? This is a cubic graph. We're going to also touch on that soon. This is just a circle, right? This, you don't work with things like this in grade 12. This is basically a parabola that has undergone inverse, right? However, you also don't work with sketches, particularly in this format. However, this you will also need to be able to say whether or not it's a function. So we say that some of these are functions, some of them are not functions. So we specifically mentioned that a function is a graph that passes the vertical line test, right? So when we refer to the vertical line test, so what we mean by the vertical line test is that you will note with all these graphs, right, we have put there two lines that are vertically going downwards for each of our pictures, right? So what you will note is for some of these graphs, right, the red lines are only touching the graph once, and then for some, the red lines are touching the graph more than once. For example, this is a straight line, right? We consider this a function because it passes our vertical line test, right? So anything that passes the vertical line test, it means that if you draw a vertical line going straight downwards, it only touches the graph once. You see, I can draw as many lines as I want. As long as a specific line only touches a graph once, that graph is considered a function, right? Same here. This passes the vertical line test because any line going vertically downwards touches the graph once, right? This same thing touches the graph once, touches the graph once. These, however, are not considered functions. The reason is they fail the vertical line test, right? For example, this vertical line touches this graph twice, touches this graph twice, a circle, right? Same here. Here 3 times, so this is definitely not a function. This same is also not a function because it fails the vertical line test, right? So all these at the top here, we can consider these functions, right? The ones at the bottom are not functions, right? So to make things simple for yourself, anytime you're going to be asked whether or not a graph is a function, you will particularly usually be given a picture, right? So whatever your picture looks like, for you to test whether or not it's a function, you just draw the vertical line test, right? Or you just perform the vertical line test. And we said if it touches your graph once, it's a function. If it touches it more than once, it's not a function. So before we work on inverse in particular, this is very important because it is one of those 1 mark, 2 mark questions that will always be there. However, you need to be able to answer them. So to kickstart ourselves, right, on inverse functions, one big thing we all want to keep in mind is that inverse functions, it's very simple, right? It's one of your simplest topics in grade 12, right? It's going to be, yeah, it's a easy, it will always be, one of those questions where you'll easily get marks. So key thing is, firstly, to kickstart ourselves, right, we have here a basic parabola, right? We know that this is a basic parabola. Main reason is it's on the origin and nothing has been done to it, right? So with inverse, right, when we speak of inverse, all we are talking about is we will basically be putting ourselves in a situation where we reflect our graph about the line y is equal to x, right? So in simple words, inverse is a reflection of a graph about the line y is equal to x. So if I reflect this picture, right, about the line y is equal to x, this is what it's going to look like. Okay, so before we do really get started, right, firstly, we have here a basic parabola, right? And if you reflect this graph about the line y is equal to x, this is the picture that you get, right? Remember, a reflection is just a matter of you getting a mirror image of whatever you're dealing with. Like, for example, this portion of your parabola, right? Its mirror portion is this portion down here, right? You see? That part there mirrors that part down there. And then this portion of your parabola there is mirrored by that portion of your parabola. You see, this tiny portion is reflected and it is a reflection of that tiny portion. This slightly curved portion is a reflection of that tiny curved portion. So for now, this may not be very clear, right? However, the key thing is this will get very basic, right? We know that this is a normal parabola and then this is its reflection. So key thing is, right, our second parabola there, right? Firstly, we know that I called it a second parabola, but firstly, this picture is actually not a function, right? Because it fails the vertical line test, right? This portion here, right, this portion there that looks like this is not a function because it fails the vertical line test, right? We know that the original picture of our parabola looked like that, right? And we said when you perform inverse, you reflect it about the line y is equal to x, and then this is what it will look like. It won't be a function, but then this is what it will look like. So the key thing with inverse, what makes it simple is here we know that this is an equation of our basic parabola, right? Getting an equation for the inverse of your original graph is very simple, right? And we're going to work on how you can go from having an equation of a parabola to having an equation of the inverse, because that's one thing you also will always need to be able to do with inverse functions. So I've labeled these 1 and 2. So we know that the equation of the first one is just y is equal to x squared. If they want us to get an equation of this graph's inverse, this is all you need to always be able to do, right? With inverse, if you're going to go from an original graph to the inverse of a graph, this is one key thing, right? This equation of our parabola will normally be given in the form f of x, right? We know that any time you will be referring to the inverse of a graph, this is the symbol that you will be using, right? So we know that this is our original function, the inverse of our graph. We don't know what the equation is there, but we said we are now going to work on how to get that equation, right? So firstly, to go from original graph to the inverse of a graph, this is all we need to do, right? Your x, you make it equal to y, and then your y, you make it equal to x. So this is what I mean. The original graph looks like this. If you're going to perform inverse, you basically just need to swap around x and y. What that means is where y is, right, you're going to drop x there. Where x is, you're going to drop y there, right? You basically performed inverse. The only key thing is you don't want to leave this like this. You always want to make y the subject of the formula. Now, in making y the subject of the formula, we know that you're going to square it both sides, and then your other side will have plus or minus. You don't want to leave this like this, right? Because anytime you have performed inverse, any graph that is the inverse of an original graph, you will always want to have y with this inverse symbol, right? So your final answer will just look like that. This is the original graph, and then this is the inverse of the graph, right? This sketches this picture, this sketches that picture, right? It's basically that simple. So to actually also show how simple inverse is, because the one thing you'll note is I will keep saying the word simple because that's the idea. Inverse is simple. So firstly, you note how here, if you note here, we say that if you're going to go from an original graph to the inverse of a graph, all that happens is your x becomes y and your y becomes x, because that's like the essence of inverse. Literally every single x and y coordinate in our original picture, right? For us to have this inverse here, all that has happened is all the coordinates of your original graph basically all swap around. Meaning, for example, if let's say this coordinate here, right, is say -3 coordinate 4. Let's say that coordinate is -3 coordinate 4, right? We know that when this point is reflected about the line y is equal to 0, it's going to be somewhere down there, right? Where this point here, these two values are just going to be swapped around. Literally, right? That's what inverse is. Every single x value and every single y value in your original picture, if you get the inverse of that graph, your coordinates basically just swap around. Like this point here is going to be 4 coordinate -3 because it's a reflection of that point there. So without trying to make anything seem complicated, always remember that an original graph and its inverse, all that happens is all the coordinates of your one graph all swap around, right? Every x value becomes y, every y value becomes x, hence why your sketch will always somewhat flip around, right? It will always be a reflection about the line y is equal to x there, right? And hence why, again, when you get the equation of the inverse from an original graph, all you do is y becomes x, x becomes y, right? Like what we did there. Where y was, we threw x in there. Where x is, we threw y in there. And then we just made y the subject of the formula, right? So before we finish up, right, we said here, y we made equal to x, x we made equal to y, and then we just made y the subject of the formula. This is what we ended up with. So this is a basic example of what inverse is. We are now going to work on inverse for other kinds of graphs, right? But then what you will actually note is with inverse, it's the same principle for all graphs. Okay, so this is an exponential graph. It's a basic exponential graph. The other good news is when you're going to be working with inverse, particularly in grade 12, you are also generally always going to work on very basic functions. So just keep that in mind, right? So if we have an equation of an exponential graph and they want us to get the inverse of this exponential graph, we firstly said whenever they ask us for inverse, right, what they will normally do is they can ask it in words, give the inverse of this graph, or they can ask it in symbols, right? We know that if they are asking for the inverse of k of x, this is what they can just also have there, right? So we mainly say from our previous example, the very first one, whenever you need to get the inverse of a function, all that happens is y becomes x and then x becomes y. So in a scenario where you're given your equation in this format, you can also rewrite it as y is equal to 2 to the power of x, right? So we know that this is the original graph. If you want to go from the original graph to the inverse of your function, we said all you need to do is swap x and y, and then you make y the subject of the formula. So for us to get the inverse of k of x, this is all we're going to need to do, right? We know we're not 100% done by far, because here we have basically swapped x and y, right? Where x is, we've thrown y there. Where y is, we've thrown x in there, right? So instead of us maybe thinking of us swapping the two, you can literally think of it in terms of any x in your equation will become a y. Any y in your equation will become an x, right? Just in case you have cases where you have multiple x values. However, for your grade 12 inverse functions, remember we mentioned it's always going to be the basic stuff. So here we need to get y as the subject of the formula. So you may be asking, how are we going to do that? Especially if you haven't done logs, right? Because our next step here, we're going to need to use logs for us to have y on its own. So before we can do that next step, we just need to give an idea of what logs is. So we mainly use logs when we need to work out an exponent, but we cannot work out the exponent using trial and error. What I mean is, if we had something like this, right, 2 to the power of x is equal to 8, we can basically see that x here is just a 3. We can guess that. We don't actually need to guess that. It's a simple exponent question, right? However, if we had something like this we cannot work out using our head, right? It's not that blunt. It's not straightforward, right? And then this is, I'm literally putting there 3.5, not 3 times 5. So 3.5 to the power of x is equal to 100. We don't know what x is. We cannot work that out using our heads. We would need to use logs, right? So logs basically helps us work out an exponent when the exponent is not necessarily basic. So back to our inverse of k of x. We said this is not complete because we need to make y the subject of the formula. Okay. So with logs, this is the essence of logs. We said logs will help us isolate the exponent and then everything will go on the other side. So anything in log format will look like this. Right. So what I've written down here should not seem funny. It may at first because this may be very new, right? So what you want to keep in mind is if you check on your calculator, right before the on button, you have a log button there, right, which has 2 slots open, right? So that's what you're going to be using from now on, right? You're going to use that quite often. But before we jump into that, firstly, when we go from this scenario to a scenario where y is on its own, remember y is our exponent, right? So our exponent will be on its own. You will have log on the other end. Whatever the base was will be the value there, and then whatever x is, that's just going to be on your far right. So to make things simple, right, what we have here is in this format, right? We have a value here. It is equal to a base to the power of an exponent. So our task is to just have the exponent on its own, right? Log on the other end, base will be there, and the value will be there. So to just clean this all up, right? This is what our answer is going to look like. It's very simple. We said we have a value here. It is equal to a base to the power of an exponent. So if you want to reshuffle this to have y as your subject of the formula, all you need to do is you put y on its own, right? And then you put log with a base and a value there, right? The base of the log will always be whatever the base of your exponent was, and then your value on the other end will just be the value that you put there, right? So this, before you leave it, k of x to the power of a negative with log 2 with x there, right? So we know that anytime you're asked to give the inverse of a graph, you are just going to swap x and y around and then simplify. Only when you deal with an exponential graph will you most of the time need to use logs for you to isolate your y, right? But we said it's that basic. If you want to make your exponent the subject of the formula, you write it as the subject of the formula, and then you equate it to log whatever the base was with the value on the other side there, right? So for now, this is what you want to keep in mind, right? Logs, very simple. Inverse, also very simple. So what you may be wondering is what the sketch is going to look like, right? So the sketch itself is going to look something like that, right? We know that it is a line that is basically reflected about where x is equal to y, right? We know that our original graph, if you reflect it about the line y is equal to x, it will look like that. You can see these are just mirror images of each other, right? And we said all coordinates for that picture will be all these coordinates just swapped around.